Hi guys, last piece that we're going to deal with solving the multi-step inequalities. So again, I'm going to start out a little bit with the graphic organizer. Remember, we're going to use this filling in our topic here and then working our way around. We basically have 4 only examples in here, so there'll be one of these that will be left open depending on where you start. Okay, so I'm going to start with the inside center part here, and I'm going to label it. This is solving multi-step inequalities, part 2. Now, the good news is, again, we have only 4 problems with this that we're going to look at, 4 examples. 2 that have some fractions in them, because we all know fractions are going to make us a little crazy when they get into big problems. And also, we're going to look at some that are not always, I would say, normal problems. So we'll look at some exceptions to the rules. So let's take a look at our first one. So just like I did on the last one, I'm going to take my page and I'm going to turn it a little bit, if I can manage to get a hold of the side of this here. There we go. I'm going to turn it like this, not for any other reason than it might give me a little bit more room to write down the pages I'm going to solve. So on this first one, I guess maybe I'll turn it just a little bit more. There we go. So on the first one, I'm just going to name this as A, and I'm going to write my first problem. Now, before we even start this problem, I do want to say, be conscious of how much space that you're using. If you write big and huge, you might need to add a Post-it note or something to this if you run out of room. So I just want to make sure that you're kind of being aware of that from the very beginning. So I'm going to give you kind of a crazy problem here. So 5x over 6 plus 1/2 is greater than or equal to 4 plus 2x over 3. Now, one of the problems, I think most students look at this and say, holy crap, there's a lot of fractions, which is true. And if we could somehow get rid of the fractions that are in here, it would make our problem way easier. So to figure that out, we need to look at our bottom numbers of the fractions and think about how to get rid of the fraction altogether to make it easier for ourselves to solve. So if I'm looking at this problem on the bottom, I see 6, 2, and 3. So I want to go back to that memory of middle school when we talked about fractions. So let's think about common denominators for a minute. So if I have 6, 2, and 3, I want to think of the smallest number that goes into all of those. So the smallest number that they would go into. So 6, 2, and 3, the smallest number that they would go into if I had to find a common denominator would be 6. Now, it could also be 12 or 24 or 18. There are multiples that could work, but we want to choose the smallest number we can to make it easier for us. So if my common multiple is 6, that means that I'm going to take this whole thing and I'm going to multiply it by 6. So I want to show you what that means. So I'm going to take every single term that's here and multiply it by 6. So 6 times 5x over 6 plus 6 times 1/2 is less than or equal to 6 times 4 plus 6 times 2x, over 3. So what I have done is I multiplied by 6 because it was a common denominator, and I multiplied every single term by it. Now, I'm going to use my highlighter just for a second so you can see this. But on these problems, I want us to focus on the number part. So those are the number parts. Now, on the first one, I would say multiplying by 6 and dividing by 6 are opposites. That means that for that term, you're left with 5x. Now, this whole part is completely numbers. There's no variables. So if I do 6 times 1/2, that basically means 6, and half of 6 would be 3. Now, what you can do, and we are going to talk about Desmos more in class, that free online calculator, but you could actually type this whole thing into the calculator and see that it would equal 3. So don't be afraid to use the calculator on this. So I'm going to bring this down. Now, this part is strictly numbers. So 6 times 4 is 24. And then if I look at the number part here, basically that's like saying 6 times 2 is 12, divided by 3 would be 4. So it'd be 4x. Now, if you wanted to, you could actually enter it like that. You could do 6 times 2 and then divide it by 3 and get your answer. So here's the deal. We started out here, but look at how much easier this looks right now. Because on that one, I've gotten rid of all the fractions, and now they're whole numbers. So now we're just going to go through and start to solve. So remember, if we have variables on both sides, let's move everything, all the variables over to the left side if we can. So we're going to move this. So the opposite of adding 4x is subtracting 4x. So 5x minus 4x is 1x. Plus 3, less than or equal to, or greater than or equal to 24, and then these cancel. So now my last step really is just to move this over. So the opposite of adding 3 is subtracting 3. So I have 1x is greater than or equal to 24 minus 3 is 21. And listen, don't feel like you got to divide by 1 because 1's there. Remember that 1 is there whether we write it or not. So if I wrote it like this and just drop the 1, that would be okay because I assume there's a 1 out there whether I write it or not. So there's my inequality. So if we go back to talking about the graph, 21's the only number they care about. Because it's got an equal to with it, I have a filled in circle. And they want to know where the numbers are greater than or equal to 21 at, and that would be here. So that would go here. Okay, we have one more harder one, or with the fractions, and then we're going to have 1 or 2 that are going to be our special cases. So let's go to the next one. Now remember, don't be afraid to hit pause so you can make sure you have everything written out. Okay, so I'm going to turn this one again. Just make it a little bigger so I can get the side of it here. And turn it. There we go. So now on this next one again, be space conscious on these because with the fractions, you might need a little bit more room. So this one's going to be B. So 3 over 7 plus 9x over 14 is less than 1 over 14 plus x. Now, before we do anything, one thing that I might do is I'm going to add a 1 there just so it's easier for me when I'm going to actually go through and solve this. Now, we want to get rid of the fractions like the last one, so we're going to focus down here. Now, the good news is 2 of them are exactly the same. So really, I'm trying to think about the smallest number that 7 and 14 will both go into. And I know the smallest number that they can both go into evenly would be 14. So that means on this one, I'm going to multiply by 14. And that's every single number. So I'm going to do 14 times 3 over 7 plus 14 times 9x over 14. 14 times 1 over 14 plus 14 times 1x. So now I'm going to go through and I'm going to start to cancel these out. Remember, the whole idea is to get rid of the fractions. So I'm going to look at just the number part. So you can go ahead on this one if you want to do 14 times 3. Thank you. Would be 42. Divided by 7 would be 6. So that's just strictly a number piece. So that part's going to be 6. Now I'm going to look at the number parts here. Now the good news is for that one, really, multiplying by 14 and dividing by 14 are opposites, so they cancel. So you'll be left with 9x. Now the good news in this one, you're going to see that multiplying by 14 and dividing by 14, so those will cancel. You're going to be left with 1. And then on this one, 14 times 1 is 14, and I'm going to put an x with it. So now, instead of having all these crazy fractions out here, I've gotten this simplified. So now I'm just going to go through and start to solve. So remember, if there's 2 variables, we're going to get them all on the same side. So we'll all move them over to the left. So the opposite of adding 14x is subtracting 14x. So I'll have 6 that'll come down. Positive 9x minus 14x will be negative 5x. I'll bring down the 1, and those will cancel. So I've got the x together. That's all by itself now, but let's get rid of this. So I assume that's a positive 6. So I'm going to subtract 6 from both sides. I have negative 5x is less than. 1 minus 6 is going to be negative 5. So to get x by itself, I'm going to have to divide both sides by negative 5. So remember, this is one where you're going to flip your sign. So that means it's going to go to greater than because it was less than here. And negative 5 divided by negative 5 is 1. So that's my final answer. So if I were going to graph, 1's the only number they care about. Because this doesn't have an equal to with it, that means it's going to be an open circle. And they want to know where the numbers are greater than 1. So greater than 1 would be on that side. I think you've noticed in every single one of these I graphed above the line because I want to be able to see the line and know what numbers it includes, and it's just easier to do it above and still be able to read it. Okay, let's look at the two kind of ones that are different, really the ones that are different than everything else. So I'm going to do the same thing I did the last time. Turn this. We want to be able to have that longer part. Kind of going across there. I'm going to make this one C. Oops. I don't know what just happened there, but let's fix it. There we go. There's C. And C, I have 6, x plus 3 in parentheses is less than 5x plus 17 plus x. Now again, don't be worried about stopping the video so you can write stuff down. That's completely okay. The only thing I might do here is I might add the 1 from the beginning, and then I'm going to focus on this side because it's got the parentheses. So I'm going to add a 1 there, and then remember, if there's a number out here in front of the parentheses, I'm going to distribute. So 6 times 1x is 6x. And then 6 times positive 3 is positive 18. 5x plus 17 plus 1x. I brought everything else down. Now, the only thing I might do is I notice that there are 2 x's on this side. So I probably would take those 2 and put them together. So 5x plus 1x is 6x plus 17. Bring the other side down. I wonder if you notice right now that you have positive 6x on both sides. So notice what happens in this one when I start to kind of move stuff. Remember we said we want to take all the x's and move them on this side. So if I have positive 6x, the opposite of that would be negative 6x, or subtracting 6x. But I want you to notice what happens. The 6x cancels on both sides. There's no x's left. So you're left with 18 is less than 17. Now, first of all, there's no way in heck that that's a true statement. 18 is not smaller than 17. So what you have left over is not a true statement. Then that means that there's no solution. Now, the reason there's no solution is because no matter what I went back and put in for x back here, there's no way that I could make 18 be less than 17. There's no way that that would happen. So I just want you to keep in mind that's why that's true. So if your x's completely cancel out and what you're left with is not a true statement, that's going to be no solution. That's one of those exceptions to the rules kind of thing. Okay, let's see one more of those. And this is actually the last one that's going to go on this foldable. Okay, again, I just turned my paper so I could write in this direction. And my problem is going to be D. So D is 3 parentheses 3x plus 2 is greater than or equal to 4 plus 9x minus 3. So we're going to go through a little bit of what we did in the last one. We're going to start by distributing this to each value. So 3 times 3x is 9x. 3 times positive 2 is positive 6. Bring down my inequality. Now, on this side over here, do you notice that there are 2 just regular numbers? So I could put those together. First of all, I might bring the 9x down just so it's taken care of. But if I do 4x minus 3, it's going to be positive 1. And now I'm going to go through and try to get the x's on the same side. So I'm going to move this over there. So the opposite of positive 9x is negative 9x. So I'm going to subtract 9x. See how they both cancel again? But I'm left with 6 on this side and 1 on this side. Now, if I look at that, that's actually a true statement. 6 is greater than or equal to 1. So if what you're left with is a true statement, then your solution is going to be all real numbers. Now let me tell you what that means. That means that if I went back here and I put in any number I wanted for x, that it wouldn't matter, because by the time I got done, all the x's would cancel out and what I'm left with is a true statement. So let's talk about what the graph would look like. The last time I didn't graph anything because it was no solution. But think about it. If I put, let's just put a 0 there just for a point of reference. But if it's all real numbers, it means it could actually be anything on the number line and it would be true. Because I could pick any number, and if I were to go back to this problem and plug it in for the x's, they would somehow cancel out, and I would always be left with that true statement. Okay, we'll work on a couple more when we get back together in class.